Hey everyone, we're going to tackle a really big question today. How do you take these huge global challenges and, shrink them down into something we can actually solve? It sounds impossible, right? Well, that's exactly what we're going to get into.
I mean, it's a huge question, isn't it? You see the headlines every single day. Climate change, not enough resources, natural disasters. It's a lot. It can feel pretty overwhelming. But here's the thing. What if there's a proven method, a kind of creative but systematic way to turn all that noise into actual real-world solutions? All right, so before we can even talk about solutions, we first have to get a real sense of the scale of the problem we're up against. And look, this isn't about just putting a Band-Aid on things. We're talking about tackling these massive shifts happening in our planet's systems. So let's start with a really core issue. Basically, the things we do as humans are, well, they're ramping up the Earth's natural greenhouse effect. We're trapping more heat. And this isn't just a simple A plus B equals C kind of problem. No way. This is the engine that's driving this whole chain reaction of changes all over the world. And here's a perfect example of that complexity I was just talking about. All that extra CO2 in the atmosphere, it doesn't just hang out and warm up the air. A huge amount of it gets absorbed by our oceans, and that actually changes their basic chemistry. We call it ocean acidification. See? It's a perfect illustration of how one thing can have these massive ripple effects in a completely different area. And that's exactly what makes these challenges so tricky to figure out. So at the end of the day, what we're really seeing is this fundamental shift in the very patterns our world operates on. And these are what we call grand challenges. They're all interconnected, they're messy, and there is no single easy answer. You just can't find one. So they demand a totally different way of thinking, something more structured and definitely more adaptive. Okay, so the problems are big. We've established that. But you know what? Humanity is actually pretty incredible when it comes to solving problems. We have a blueprint, a kind of playbook that's been used to create, well, pretty much every piece of technology you see around you. Now seriously, just think about it for a second. The very device you're watching this on right now, whether it's in your hand or on your desk, the chair you're sitting in, the pipes that bring clean water to your tap, every single one of them started out as a problem that someone needed to solve. And they all came to life through something called engineering design. And this is that process. Now what's really cool here is that this might look like a simple 1 through 6 list, but it's not. The secret is that it's actually a loop. It's not a straight line where you get to the end and you're done. It's a cycle. You're constantly improving. You define the problem, you build something, you test it, and then, this is the crucial part, you take what you learned and you go right back to make it better, over and over and over again. Okay, so that's the theory, right? But what does this actually look like in the real world? Let's break it down and walk through a concrete example of how engineers take a problem and turn it into a tangible solution.
All right, step 1. And honestly, this might be the most critical step in the entire process, defining the problem with crystal clarity. This really boils down to 2 key things. On one hand, you have your criteria. This is the must-do list. What does the solution absolutely have to accomplish? And on the other hand, you have your constraints. These are your limitations. What's your budget? How much time do you have? What materials can you use? And you can't just guess. This step takes a ton of research to really understand what's needed. Okay, let's apply this to a really high-stakes example, building a structure that can withstand an earthquake. The problem is obvious: protect people and minimize damage. The criteria? The building has to maintain its structural integrity. It has to stay standing. And the constraints? Well, you've got to follow all the local building codes, you have a budget you can't go over, and you can only use certain materials. Suddenly, those abstract ideas get very, very real.
So once you have a solid plan, you can't just jump ahead and, build a full-scale skyscraper. Not a chance. You have to build a model first. We call it a prototype. And whether that's a digital simulation on a computer or an actual physical model, this is the moment where your ideas crash into reality for the very first time. It's how you figure out what's working and what's definitely not, before you spend a ton of time and money.
And that journey from idea to object is pretty cool. It often starts with something as simple as a sketch on a piece of paper, just to get the basic shape and idea down. From there, it gets translated into a super detailed digital model, using something called CAD software. This lets you get everything perfect, down to the millimeter. And then, finally, you create a physical prototype. And that's the magic moment, the first time you can actually hold your idea in your hands and see how it feels and works in the real world.
Now, testing. This is where the magic really happens. You don't just build a prototype and hope for the best. Nope, you collect hard data. Take this water filter example. You can clearly see that design C is performing the best.
But the most important question isn't which one won, it's why did it win? The data you get from these tests is what tells you exactly what to keep, what to throw out, and how to make the next version even better when you go back into that design loop.
So look, this whole thing, it's not just some complicated process for engineers and white lab coats. It's so much more than that. It's a mindset, it's a powerful way of thinking that literally anyone can use to tackle problems, big or small, in a way that's both creative and super systematic.
And when you start using this process, you naturally start building these essential skills. You learn how to be incredibly creative, even when you have limitations. You start thinking critically, looking at the data and asking why. And, maybe most importantly, you realize that the very best solutions almost always come from working with other people. It's really a toolkit for innovation.
And this is where we come full circle. That exact same process, that loop of build, test, learn that was used to design the phone in your pocket, it's being used right now to tackle those grand challenges we talked about at the beginning. It's that cycle of constantly improving that makes it so perfect for these huge, messy problems. It lets us build a better future, one carefully tested and improved solution at a time.
So yes, the world has some really complex challenges, but we also have this incredibly powerful process for creating solutions. That whole journey, from seeing a problem to actually building something to fix it, it all starts with just one question. So I'll leave you with this thought. What problem will you solve first?